As a species, we are driven by a desire to understand and make sense of the universe around us. We identify and classify every animal we find. We have landed people on the moon and sent probes into deep space to uncover the secrets of the cosmos. We have photographed the surface of other planets and witnessed our own blue planet as a speck in the distant infinity of space. Despite all this, we have still explored just 5% of Earth's oceans. Most of that knowledge lies in shallow waters, while the depths beneath remain a mystery. To this day, we have caught only glimpses of the weird and wonderful life that thrives in the sunless world of bottomless trenches and endless deserts punctuated with islands of activity. Every discovery challenges and rebuilds our understanding, from phenomena like deep-sea gigantism driving unique adaptation in deep-sea life, to alien-like ecosystems full of life forms unlike any others we have encountered. We only began our journey of discovery in the deep in recent times, as exploring these harsh conditions requires highly advanced technology that simply wasn't available to us until now. But people have been enchanted by this peculiar other world for centuries. Throughout history, tales of sea serpents and monsters have captivated the minds of all who journey out among the unforgiving waves. There is a distinct sense of wonder that the endless, bottomless ocean evokes, but this comes with a sense of fear. For many, the depths represent a realm of darkness, silence, and death. But when we peer closer, we find that it is in fact a place of beauty and mystery, where creatures come in spectacular shapes and unimaginable sizes, and divergent evolution has forged species that are unlike anything we have found elsewhere. It all began in 1521, when Portuguese explorer Ferdinand Magellan attempted to measure the depth of the Pacific Ocean. He cast a 2,400-foot weighted line into the sea, but it did not touch the bottom. 200 years later, in 1818, explorers first captured worms and jellyfish from a depth of around 2,000 meters, offering up the very first evidence for deep-sea life. But the idea that the deep sea was too harsh and barren to support life persisted even then. In 1842, naturalist Edward Forbes proposed the abyssus theory, in which he stated that biodiversity decreases with depth and that life cannot exist deeper than 550 meters. As we have found in recent years, he couldn't have been further from the truth. In 1850, further evidence to challenge his theory arose when a rich and abundant ecosystem was discovered by biologist Michael Sars, thriving at 800 meters below the surface. During one of his dredging expeditions, Sars discovered the first living stalked crinoid, a creature unlike anything that had been seen before. It was a monumental find that spurred academic interest in the exploration of the deep sea, and prompted the Challenger expedition that occurred between 1872 and 1876. Led by Charles Wyville, the HMS Challenger conducted the first deep-sea exploration mission. The team discovered many new species that were uniquely adapted to life near the sea floor, and were able to prove definitively that the depths were able to support a complex community of life. In 1956, a team aboard the Calypso released the first full-color, full-length documentary, Le Monde du Silence, The Silent World, showing people around the world of the beauty and life of the deep sea. But still, the greatest discoveries were yet to come. The incredible ecosystems that thrive around hydrothermal vents were discovered only as recently as 1977. These deep-sea vents support a diverse community of life that relies entirely on chemical energy from the Earth itself, rather than solar energy. This had never been seen before. It was a discovery that challenged our understanding of life on Earth, for it was once thought that organisms simply could not survive in an absence of sunlight. Discovering these vents gave rise to our understanding of chemosynthetic bacteria that convert chemicals to energy, as an alternative to photosynthesis that takes place in plants. Similar chemosynthetic communities are also present around brine pools, where life persists on the shores of toxic lakes of death beneath the waves. The deepest place in all the world's oceans is known as the Challenger Deep, 11 kilometers down at the bottom of the Mariana Trench. Within his vessel, the Deep Sea Challenger, James Cameron completed the first ever solo dive to the bottom of the Challenger Deep in 2012 and observed some truly bizarre life. The discovery of microbial mats, bizarre-looking clumps of microorganisms living off chemicals from rocks 10,912 meters beneath the surface of the Pacific Ocean, was one observation. Data from Cameron's expedition, along with a newfound understanding of life at deep-sea vents, gave substance to the theory that life might have originated in the deep sea. The primitive and yet highly unique organisms that thrive in these ancient ecosystems may represent the early life that first developed from chemical building blocks and gave rise to all life on Earth as we know it. Discoveries like this show us the astounding potential of deep-sea research. The more of us who become inspired to see this ancient realm firsthand, the more our understanding of its complex systems and processes will advance. Deep-sea exploration is a multidisciplinary endeavor. Whether it be the biology, geology, geography, archaeology, or engineering that interests you, uncovering the secrets of the abyss poses the last true frontier of pure exploration on planet Earth. The deep is at the forefront of modern scientific research. The Nautilus exploration vehicle and the NOAA's Okeanus explorer roam the depths each day, documenting new species that were unknown to science until now, and revealing the impact our species has had on the oceanic environment. Only once we understand these impacts can we truly be able to change and mitigate the damage we have caused to these ecosystems. Much like space exploration, deep-sea exploration requires advanced instruments and technology. It is a cold, dark, and highly pressurized abyss. Salt water is corrosive and conductive, and yet still we have found a way to venture into this unforgiving realm in the name of science and discovery. Remotely operated vehicles known as ROVs carry cameras, manipulator arms, sonar equipment, and sample containers, bringing back specimens for research. The secrets of the depths are calling out. Join the mission to explore, discover, and experience the incredible world of the deep ocean. If you're interested in learning more about the deep sea, check out our Deep Sea Wonders series here on YouTube to discover its incredible habitats and the animal life that calls it home.